Great. Good morning, everyone. I'm super happy to see so many of you here. I wasn't sure. But welcome to my talk, 10 Reasons to Try Kotlin Multiplatform. My name is Pamela Hill. I'm a developer advocate at JetBrains. So Kotlin Multiplatform is a technology by JetBrains, and it allows development teams to share common code between different platforms. And perhaps you're wondering, what kind of platforms are supported by this technology? Well, first is server. That would be the JVM server side. Then mobile, so Android and iOS. I don't know if there are any Android and iOS developers in the audience. A few, okay. Some desktop and also web, which includes WASM or WebAssembly. So Kotlin Multiplatform is currently in beta, and it is going stable very, very soon. So it's a great time to learn about it, and it's a great time to get more knowledge about it and dip your toes into it. So my first reason to say that you should try Kotlin Multiplatform has to do with FOMO, the fear of missing out. There's already some big companies using Kotlin Multiplatform. And you can see here, these are some of the rock stars that are already using Kotlin Multiplatform in production, and they are featured on our case studies page. And I want to highlight just a few of them so that you know what they're doing and why they are actually using Kotlin Multiplatform. So first we have Meetup. I suppose everyone has a rough idea of what Meetup is. Hands up if you know what Meetup is. Okay, great. So Meetup is using Kotlin Multiplatform for unifying their business logic for the new organizers app. Maybe you're an organizer and you've used their app on Android or iOS before. They're using Kotlin Multiplatform. And the reason why we're using this technology is they want to simultaneously release features. So they want to release their new features on Android and iOS at the same time. And they also found that their team productivity was improving, it was increasing. And they found that their collaboration and their communication between their Android and iOS teams was actually also improving. Next is Netflix. I don't know if there's Netflix fans in the room, but I think a lot of people at least know what it is. So Netflix used Kotlin Multiplatform for their Prodigal app for film and series creation. So it's not the main app, it's the film creation app that they used for it. And they found that they were using Kotlin Multiplatform in order to speed up the feature release cycle, so they could release their features just that much faster using Kotlin Multiplatform. And next, Philips, a Dutch electronics company, and they were using it for their cloud SDK. So the reason why they were using it was they wanted to simplify the way that app developers integrate with their cloud. And they found that they could implement their features faster, that maintenance was easier, and that the collaboration between their teams was also better, that communication and knowledge sharing was so much better. So if you're interested in the case studies page, you can have a quick snap if you want to, and you can go have a look at how different companies are using Kotlin Multiplatform for their use cases and their problem sets, and how they can sort of get started with how they got started and what they used it for, and how, the problems they encountered and how they solved it. So it's a very useful page. My next reason is that there's an extensive list of supported platforms. So we spoke about this a little bit earlier. We talked about server, and for mobile, we talked about Android and iOS. And for desktop, there is macOS, Linux, and also Windows supported. But for web, there's also JS and WASM. Now, perhaps you haven't heard of WASM before, so just as a little aside, I want to talk about how it's a binary instruction format for portable virtual machines, and it is basically smaller and faster than JavaScript. And you don't actually write your code in WASM, you write your code in Kotlin, or maybe Rust or Go, and then you compile it into WASM. And it's already supported by most modern browsers, and also Node.js. So I want to illustrate or support my reason that my reason that you should try Kotlin Multiplatform with the story of Quizlet. Now, Quizlet is an educational platform. It's actually quite a well-known one. Perhaps you haven't heard of it before, but there's about 50 million users every month. And they have about 10 million active installs on Android, and they have, they're top 10 in the education category on the App Store. So they actually do have a lot of users. They are using Kotlin Multiplatform actively. And it's basically just an application like on Android, iOS, and web where you can sort of learn new topics and practice what you've learned through a quiz. And so we're going to be going through the story of Quizlet now. So they tried other technologies like JavaScript and React Native and even C++, Rust, and Go. But they found every time there was something that was a bit strange, a little bit off, that they didn't quite like. So eventually they settled on Kotlin Multiplatform, and they're using it with a lot of success for Android, iOS, and web. And this was the results. They had type-safe APIs when marshalling objects. So they used to have to convert between types, and now they not only had type-safe APIs, they also had null-safe APIs because they were using Kotlin. They also had better performance on Android and iOS. For example, on iOS, there was a 25 times improvement in the grading algorithm that they were using. The app size also decreased, and they had a better developer experience because now they were using Kotlin, which it's not only a great modern language, but it also has really great tooling. And what I found really interesting about this sort of case study is that that different team members were sort of keen to contribute to the shared code. They had the Android developers, which is quite normal, but they also had iOS and server-side developers that were keen to write shared code, and eventually even the web developers were like, that looks pretty interesting. So it was actually a pretty nice case study to look at. Another scenario that is quite typical, and there was a gentleman here earlier that wanted to know whether he should attend this talk, and I said, that there is a scenario where you could share code between client and server, and that it is actually quite common in Kotlin Multiplatform. So before, in one of my previous companies, I actually had this. We had this scenario where we wanted to share our data models between our clients, which was web, Android, and iOS, and our backend, which was in Go. So we used a technology called protobufs, or protocol buffers, and it is a language-neutral, platform-neutral language from Google. So what you have to do is you take these files that is in a particular format, and then you sort of generate code into you can use, for example, Square's wire technology in order to generate the Kotlin version of whatever protocol buffer you've generated or created. So you can use it with any language. You can use the solution with any language, like Go. Whenever there's a generator, you can use it with that language. But you have to learn yet another format. And you have to also generate, for each change that you make in your proto files, you have to regenerate the data classes again, and then also, commit them to, your Git repo and make sure that everyone is synced and on the right data model and so on. So it can be quite, resource and it can be quite an intensive process just to change one field on a proto file. So the alternative is to share data models with something like Kotlin Multiplatform. And you can use a familiar language, Kotlin, with great tooling, And you can write once and use it everywhere. You can just use it as a dependency and write and use it just like that. But you have to make sure that all the platforms that you are using actually is supported by this technology. For example, on the server side, we actually don't support Go. So you have to sort of stick to the server-side languages, like the JVM languages for server-side. My next reason for saying that you should try Kotlin Multiplatform has to do with community. You know, community makes such a huge difference in the uptake and the experience that people have with a particular technology. So we have a very large Kotlinlang Slack workspace with about 56,000 members, and there are some channels for multi-platform and Compose iOS as well. And you can ask questions for JetBrainers and Googlers and other experts like those creators of open source libraries. And you can have your questions answered pretty much very, very quickly. So something that's really important with adopting a new technology is how large its ecosystem is. And so it's really important to know, like, what amount of libraries are there? Is my use case for a particular, like what I want to do in my app or what I want to do on my server side, on my server app, is that supported? So it's really important to know, is that ecosystem big enough already? And you can see here in 2021, there's a definite uptick in the amount of multi-platform libraries by year. I also want to give a couple of shout-outs, and I would really recommend, if you're keen on trying Kotlin Multiplatform, that you give these folks a follow. I think one of them you already know pretty well, but that you give these folks a follow because they are, very knowledgeable and they are very well known for their expertise. So Google recently started becoming more invested in Kotlin Multiplatform. And they're actually actively taking Jetpack libraries and moving it over to libraries, making it multi-platform instead of just Android-focused. TouchLab is a US-based company that are, on the forefront of creating tutorials and documentation for Kotlin Multiplatform, but they're also creating a lot of open source libraries like the KMM Bridge, which you can use to bridge across from a local to a remote in sort of distribution environment. And they also have Sky that they recently sort of released, and it is basically a technology that just simplifies and smooths over that Swift to Kotlin interop. John O'Reilly creates really great sample apps, and he is really the person to follow if you want to know how to architect a Kotlin multi-platform app properly. Philipp Lackner from Germany is really well known for he's a little bit of an influencer, and he's really well known for his tutorials on YouTube, and he's very knowledgeable about the topic as well. Sebastian Eigner and Garth Gilmore from JetBrains are the people to follow about the latest news in Compose multi-platform. Lena Stepanova has really impressed me with her tutorial on just creating everything from client side all the way through to server side Kotlin multi-platform. So what she did was she created an app called KM Pizza, and it shares code between, just business logic between Android and iOS, and the UIs are native. But she's taken that and she went all the way to the server side, made it a KTOR server, and then put it on Docker, and it connects with AWS as well. So it's a very extensive tutorial. And Thaddeus Chris recently spoke about Kotlin Native for Android developers. He's also a very avid speaker, and he really knows his stuff because he was a Swift developer before. So he knows how to do Kotlin in Swift interop really well. So the first technical reason for using Kotlin Multiplatform has to do with unifying business logic, and that means avoiding duplication, right? So I want to tell you the story of the Wonder app by Baidu to sort of illustrate this reason. Now, Baidu is the largest Chinese language search engine, and the Wonder app is an educational and entertainment app for younger users. And they use Kotlin Multiplatform in order to avoid duplication, but they started out with two native apps. They had an Android app and they had an iOS app. And they had a couple of problems. These are the problems that they actually, encountered. They had inconsistencies with the app experience. They had a high cost of verifying the business logic, so testing the logic and maintaining. When they were trying to maintain this code base, it was starting to get out of hand. So they found that the complex and inconsistent business logic of the iOS and Android platforms led to an increasing maintenance cost for the app. So they decided to give Kotlin Multiplatform a try, and they started by unifying the data layer. It was just a little experiment. They were unifying the data layer. And so they did the data model, some RESTful API responses, the JSON data parsing, and the caching logic. And the experiment was successful. I know you were like on the edge of your seat. Was this experiment successful or not? It was. It would be rather strange if I told you about a failed experiment. But they had a successful experiment. They decided to increase the scope. And then finally they decided to adopt a user interface pattern that would make it easier for them to share even more code. And that pattern is called MVI, or Model View Intent. So that enabled them to unify their interface logic, and then they did the low-level data, the processing logic, and the UI processing logic. So this was the results. So they found that they had a more consistent experience. Everything was working the same on Android and iOS. There was a reduced cost of maintenance and testing, and they improved their productivity. My next reason is that you can use it in new or existing projects. Often with a technology, other cross-platform technologies, you have to start from scratch. You have to start all over with a new technology, whereas with Kotlin Multiplatform, you can start with a new project if you wanted to, or you can start using it in an existing project. And we've just had a look at the existing project scenario, which was the Wonder app by Baidu, where they had an Android and iOS app, and they decided to start unifying some common code. But the new project scenario, I can tell you the story of 9gag, the sort of meme, funny page, funny video website. And they are actually using Kotlin Multiplatform on Android, iOS, and web. And they tried other technologies like React Native, Flutter, and finally they settled on Kotlin Multiplatform. And they started out on Android, and then they sort of extracted things into a library and used it from iOS. Next, you can start sharing gradually. You don't have to share a big blob of code. You can start really, really small. You can start with constants. Maybe there's something that people are constantly mistyping, like a formatting string, or something else that's small, like sales tax, or something that you can definitely make common. You can migrate some small common utilities, like maybe your email validation or your password validation, or then you can go a little bit bigger and migrate business logic, maybe some transactional stuff. So this is a recent survey that we did with regard to what people are actually sharing. And this is only for Kotlin Multiplatform, not the UI parts. So you can see that a lot of people are sharing data validation and serialization, networking, and internal utilities. But, there are a few other use cases that are sort of lagging behind a little bit. Next, you can choose what to share and what to write natively. So you can see this is a very complicated diagram, and that's actually the point. Because if you are sharing code between iOS, if you're not sharing code between iOS, Android, and desktop, you have so much code in your code bases. You have if each application has its own sort of layers, they're all duplicated. And so for example, if we look at Android, we have a data and core layer, a business and domain layer, a presentation layer, and then a UI layer on top of that. That's a lot of duplication. So if this is now before Kotlin Multiplatform, but what happens with Kotlin Multiplatform? So much simpler. We can now share the business logic, which is the data and core layer, and the business and domain layer. But remember I said before, you can share something just very, very simple. This is just the normal case, but you can definitely share something that's even smaller. So here, we're actually not doing the presentation layers and the UI layers as a shared component. We are doing them natively. You can choose what to share and what to write natively. So our next step is to actually share UI logic. So now we're sharing the presentation layer of presenters, view models, and controllers. We're choosing to not share the UI layers amongst all the platforms. So each UI will look native. But with a new technology called Compose Multiplatform, we can actually share the UI as well. And the only thing that's really left to share, which you can't share, is the platform-specific code. And so there's a whole lot of sharing and a lot of caring happening in this application, and not a lot actually happening at the top that's happening natively. So you are definitely avoiding a lot of duplication. But I want to reiterate, and this is really important, you can choose what you want to share and what you don't want to share, what you want to write natively. If you want to write the UI natively, yes, you can. If you just want to share some business logic, yes, you can. So here's the fun part, the UI code. So I don't know if any of you actually know about Jetpack Compose, maybe a few of the Android developers, yes. So Jetpack Compose is a technology from Google that is for creating native UIs. So it's for creating Android UIs in a declarative style. And it's built on top of the Kotlin compiler. So you write Kotlin code, you write code in Kotlin, and it is APIs for Jetpack Compose. But JetBrains took this idea further and created Compose Multiplatform. And so instead of just targeting Android, we're also targeting Android, iOS, desktop, and web. So it's a very ambitious project. So this is the current state of our platforms. We have Android and desktop in stable, and iOS in alpha, and WASM is experimental. We're still playing with that side of the technology. So I'd like to show you just how beautiful these apps that you create shared UI code with can be with Compose Multiplatform. And this is an official sample called the Image Viewer app that runs on Android and iOS and desktop and web. And what's interesting about this example is that it actually integrates natively with components like the maps and the camera. Another community sample is the clone of the New York Times app. So it's not actually from New York Times, it's just an example clone app. And what's interesting about it, if you look in the lower right corner, there's actually a watch app. So we're actually using Wear OS, and we're sharing code across Wear OS. And my final point in this sort of section is really I think for a very long time, desktop development has been neglected. Before you had Qt and you had swing/SWT for Java, but recently it's more sort of Electron that they're using, but now you can use, there's an alternative to using Electron, which is more, I believe, web-based. So now there is a native way to write modern desktop apps in a declarative, great style using Kotlin. So now it's time for a little code break. I hope you're excited. So let's have a look. I want to show you how you can create a little app that, it's just a very simple app, because obviously we're not going to go into great detail about how the technology works today. But I want to show you how this app runs on both Android, iOS, and desktop. It's the same app. Okay, so first I'm going to show you if you can I'm just going to drag this a little bit. And you can see if I wanted to just run it, it's just an Android app, and then I click on run. But I'm going to take a shortcut and just run the application from here. And you can see it just has a little Hello World button. And if you click on it, it says Hello Android 33. Now, 33 is the SDK version of the device that we're running on. You can actually see that over here. And you notice also that there was an animation that went in and out of an image. And as you click on it, it goes in and out. Okay, next up is desktop. And it always pops up in the most inappropriate places, but here we go. Okay, so we click on Hello World, and it shows me that I'm on Mac OS X, and it animates in and out. Okay, next is iOS. I'm going to show you from the simulator, and we open it up. It says Hello World, Hello iOS 17.0. That's the latest version of iOS. So we can animate it in and out as well. Now, that might not seem so impressive until I show you that most of the shared code, most of the code is actually shared. It's a lot of shared code. There's just a few platform-specific details. So when we open the application, the project, it looks like this, where we have Android app for where our Android application lives, iOS app where our iOS application lives, and you can even there's a little bit of integration with Xcode, where you can open up the Xcode project if you wanted to. And there's also a shared module with where all our shared code lives. Now, inside the shared module is common main, where most of our shared code lives, and the rest is platform-specific integration code. Now, I'll explain exactly what that means a little bit later, but that is where all the code that we are integrating with platform APIs lives. But if we wanted to sort of see where all the main shared code is, it's basically here. That is the app. And we have a function called app, cunningly, and it is a composable, so it means that it emits UIs or emits UI elements. We wrap it in a theme, the material theme, so mostly Kotlin Multiplatform and Compose Multiplatform, let's be very specific, Compose Multiplatform is always material theme. There are other projects like Redwood that allows you to write completely native looking UIs, but that's not Compose Multiplatform. Then we create two variables, greeting text and show image. And initially greeting text is hello world and show image is false. So greeting text will be the text on the button, and show image will be whether to animate the image in or out. Then we have a vertical structure with the button and the image below each other. The button has some text inside of it with greeting text inside of that text element. And when we click on the button, we have we basically just change the greeting text to hello get platform name. And we toggle the show image Boolean value. There's also a little animation happening here. Ooh, it's a big animation comment. But it basically is just, when you show image is false, it will not show, and when show image is true, it will show. And it's just painting an image there. But if you were kind of listening kind of astutely, you would see that there is something interesting happening here in the form of get platform name. I wonder where this is declared. So if we click into it, we can see that it is just at the bottom of this file, and it says expect fun, get platform name, return something of string. So there's no implementation here. Now this is what is going to say OS X on my desktop, or Android 33 on my Android device, and so on. And the way that this actually works is with expect and actual. So in your common code, you say, I expect something to be there in the platform specific code, these Android main, desktop main, and iOS main sections. And that is exactly what is happening. So we mark them as actuals in those directories. And so I can go look here for Android, and we can see here we have actual fun get platform name, and then we are using the APIs of Android in this directory. So we're actually using the SDK build version in this piece of code. And similar for desktop, here we are using some JVM. I can actually just go back and just use the gutter icons. So for desktop, we can use just some JVM stuff. And for iOS, we are using platform.uikit.ui device. Now this is very important. We're using iOS APIs from Kotlin without like fanfare or anything big. We're just importing them. It's really simple and easy. So I want to show you the next thing is really about how to get the code into, how to get that app code into the actual Android and iOS apps. So for Android, it's pretty simple. If you have an Android activity, which is like a screen, you have an onCreate function, and that function is tasked with setting up the user interface. And inside it, we set up the content, and there inside it is a composable function called main view. And that composable function is basically just a bridge sitting in Android main for the app. So we're using Android main as a bridge between Android app and common main. And we're just basically calling our app, which is our greeting text and our buttons and our images. Now, probably you're interested in to see how it works on iOS. So this is iOS. We have a SwiftUI app, and inside the body of SwiftUI, we have something called Content View. And inside Content View, we have Compose View. And Compose View is actually bridging between SwiftUI and UIKit, and then making a UI view controller. And the UI view controller that it's making is actually not defined here on Swift, in Swift and Xcode and that whole ecosystem. It's actually defined back in our Kotlin app under iOS main, and we look in here, and there is main view controller. And so we're interoping between Swift, Objective-C, and then Kotlin. And we are wrapping that app in a Compose UI view controller. So it's bridging a whole bunch of stuff, but it's actually fitting it all together into one app. So in conclusion, we can share a lot, and we can share as much as we want, and this is the sum and total of the app. I think it's pretty impressive. So let's go back to our slides. Okay, so what did we just see? We saw lots of code sharing between Android and iOS. We saw calling native code from common code. That was that expect actual mechanism that we were looking at. And we saw that we could use the common code from our platform apps. something you're probably wondering about is, how does this compare to native? Now, the first thing is about experience that you have to consider is about experience. Can you use native dependencies on with Kotlin Multiplatform? And the first thing that I want to mention about iOS, because Android is just so much easier, it's almost, it almost goes without saying that it will work well with Kotlin. But for iOS, the support for Apple APIs are actually out of the box. So there are Kotlin bindings for things like Foundation and Metal, and it just works. Then the support for dependencies published as CocoaPods. There's a little bit of configuration, but not much, and you can use it just by importing it. Then there's support for dependencies not managed by a dependency manager. So it is entirely possible. And in summary, it's sort of like you make the common easy and the less common possible. And then in terms of actual performance, there is no reasonable use cases known to be significantly less performant than native or other cross-platform technologies. Now, I want to be very specific here. This is reasonable use cases, means that it affects user experience for a normal app, for example. And I also want to mention that this is for Kotlin Multiplatform, not Compose Multiplatform. Compose Multiplatform is still an alpha for some, some are still experimental. So we're not there yet with Compose Multiplatform. But with Kotlin Multiplatform, we are definitely heading in that direction of stability. And so there are no use cases that are reasonable, that affect user experience, that are significantly less performant. But we are open to feedback. If you find something that will affect your user experience, we want to hear about it and we want to fix it. And my last reason, of course, is that Kotlin is a loved and trusted language for everyone. Okay, so what do people say when they think about Kotlin? Perhaps they say it's concise. You can write really short programs. Maybe they say it's expressive, you can solve a whole bunch of problems. Maybe they say it's original, it's got some unique features. And perhaps they say it's sound. You can prove that mathematically, if you really needed to, that these programs are correct. But this is not what Kotlin is about. Kotlin aims to be pragmatic and practical. And so Andrei Breslov, the previous lead language designer of Kotlin, said that these are not, the concision and so on, the concision and the expressiveness is not what they're aiming for. Rather, they're aiming for readability over concision. Just because a program is short doesn't make it a good one. And so Kotlin aims to eliminate a lot of boilerplate, but it's also more important to write readable code than to write super concise code, right? Next, he sort of favors reuse over expressiveness. So what he was trying to say is that, yes, it's good to solve a whole bunch of problems, but it's also better to reuse those solutions to problems in libraries. Next, interop over originality. So it's great if you have a whole bunch of features and you have a super unique language, but rather stand on the shoulders of giants like Java and learn from their mistakes, learn from their successes, and sort of pick and choose the features that you want to use. It's okay not to be completely original all the time. It's also more important to be interop, to have that interoperability, because then you get to use the rest of the ecosystem in that language. And lastly, the safety and tooling over soundness. So it's really important to have a good type system that supports your tooling so that you can know before you even compile whether something is going to work or not. And the same with safety. The same has to do with making sure that you catch your errors at compile time rather than in production. So in summary, Kotlin is designed to make developers happier.
So we did a recent survey where we asked developers, does Kotlin actually make you happier? Are you satisfied with Kotlin? And 86% of them said yes. So my first reason why I say that Kotlin makes developers happier is that it makes them more productive. Now, we had a survey where we asked developers whose primary language was Kotlin, does it make you more productive? And 70% of them actually said yes. And I want to illustrate this sort of point with just one of my favorite features in Kotlin, which is called the data class. Now, here we have a data class similar to a Java record that is of a type person, or is for a person. It has a first name, second name, and surname. And the second name has that question mark at the end. That means that it is nullable. So the first name and surname, you can't ever make them null, but second name could possibly be nullable. And what's nice about data classes is what you get in the box with it. It's the setters and getters for each property. You don't have to write it or test it, it's just there. There's the equals method, the hash code method, or the functions. There's toString, copy, and also destructuring, just there for you without having to create or generate it. Another reason to be happy is fewer crashes. So, the dreaded NPE or null pointer exception was a real thing, a few years back. And we found that, when we looked at the top 10,000, not 10,000, 1,000 apps in the Play Store, if you were writing your app in Kotlin, you were 20% less likely to actually crash. And so I wanted to just show you what features we have in Kotlin that has to do with null safety, because we want to avoid crashes, and we want to avoid crashes coming from null pointer exceptions. And this is how we actually do it. So task 0, because we always start counting with 0, is to print a name. So here we're going to print the first name, second name, and surname. And we're going to use two examples. So we have Adele Blue Atkins, if there's any Adele fans in the audience, and Taylor Null Swift. So you can see that this program won't crash even though the second name is null for Taylor Swift. Then for task 1, we want to print the second name in uppercase. So we're trying to actually make this thing break. And so what we would see is that if we didn't have that question mark behind second name, we would get a red squiggly even in the IDE that would tell us that we need to add this null safety operator. And so we almost get the same result with the Taylor Null Swift, but for Adele Blue Atkins, the blue will be in uppercase. So nothing crashes, everything works as it should. And our task number 2 is if the second name is available, then uppercase it. So what we can do here is we can use an Elvis operator. You can see there's a little squiggly, a question mark with 2 eyes. And if the second name uppercase is null, then you just make that what follows the default value. And so we get Taylor with an unfortunate amount of extra space Swift instead of Taylor Null Swift. And that is how you handle nulls a little bit better in Kotlin. So lastly, it improves safety and correctness. We should be happy about safety and correctness, right? And one of my favorite ways where it handles safety and correctness better is with equality. Now in Java, you have to do person.equals for value in structural equality, but for referential equality, you have to use person equals person 2. But I think this is actually pretty unreadable. In Kotlin, rather they use equals for value structural equality, and the triple equals for referential equality. I think this reads better because you want to sort of use your mathematical existing knowledge for handling equality. You don't want to use a method. And like, this is one of my favorite like little jokes about this. It's to equals or not to equals. That is the question. And you hold the little skull. It's the Java Hamlet. It's perfect for Denmark. It's perfect. It's Hamlet. Okay, so where is Kotlin used? So we can see here that Kotlin is used a lot for Android. I admit that, but it is growing for server-side and other things as well. So 95% of the top 10,000 apps on Google Play use Kotlin, and 23% of them use it Jetpack Compose. But look at all these these web frameworks. There's Spring, there's Ktor. And I know that you recognize some of these server technologies already. I mean, I used to be an Android developer, and I know Micronaut and Quarkus as well. So perhaps I've convinced you a little bit. What's next? So my main advice is just to start small. Start with constant, a small shared irritation. Maybe you have analytics between your platforms that really gets out of sync very quickly and really irritates the whole team, or some common utilities. And then decide on an experiment plan. What do we think will happen, and how are we going to go about our experiment? Finally, how are we going to analyze our results? Something to think about when we think about our method is about team roles. Who is actively going to contribute to this code? Is it just going to be the Android developers, or maybe just in general Kotlin developers, or is it going to be the whole team or sub-teams? Workflow, how am I going to distribute my changes? Coding standards, how am I going to create nice-looking Kotlin that will also look nice in Swift? And CI/CD, how do I test and roll out my changes? And will this cause my apps to crash in production? Next, and finally, we have to gain trust and then perhaps expand the scope. So I would really recommend do a retrospective and figure out, did this really work for us? If yes, do we want to expand the scope? Do we want to share more? Maybe not. If no, why? Is there a people issue? Did we maybe underestimate how much change there was needed? Maybe people weren't ready for that change yet. Was it a process issue? Did we have impediments that we didn't know about? Or was the technology maybe just not the right fit for us as a team? So in summary, I really want to just quickly zoom through these things, but it's already used by big companies. Don't miss out. There's an extensive list of supported platforms. There's a supportive community. We're around. We want to help you. Try Kotlin Multiplatform for yourself. You can avoid duplication, which nobody likes, copy-paste. You can use it in new or existing projects, so you can use it now already. You can start sharing gradually. You can choose what to share and what to write natively. You can share UI code with Compose Multiplatform now, and you can make really great looking apps. It's comparable to native and Kotlin. Well, the last reason is because Kotlin. So my call to action is really just to start small, work out how you're going to do it, and gain trust, and then expand the scope.